here's the first example on implicit differentiation. So this is going to be very useful when x is up on top. So what we're going to do is take natural log of both sides. This strategy is called logarithmic differentiation. Okay, so I'm going to bring log here to bring that exponent of x down first. So look, I will take natural log of the left side and the natural log of this side, this one right there. Okay, oopsies. I can't do this. All right, hold on. All right, so what will happen now is, well, the left side is just natural log of y. Okay, but you see that green highlighted x, it can come down to the front. So now I will have x times natural log of x, right? So once you bring that exponent down, you're going to take the derivative of this implicitly, okay? So my next move is this. I will say I'm taking the derivative of the left-hand side and the right-hand side with respect to x, okay? All right, let's see. Remember how to find derivative of natural log function? Okay, note, a while ago, we learned that the derivative of natural log of x is 1 over that log argument times the derivative of the log argument, chain rule, right? So on the left-hand side, let's do this first. What is the derivative of natural log of y? That's going to be 1 over y, okay? But times. Now you need to take the derivative of y with respect to x. So what's that going to be? dy dx. Okay, so done with the left side. Now if you look at the right side, we have a product, right? So we're going to do a product rule on the right hand side. So the product rule says first times the derivative of the second plus second times the derivative of the first, where first is that green x, then the derivative of that x is just 1. Now the second is natural log of x, and the derivative of natural log of x is just 1 over x. So if I put these 4 pieces together to do the product rule, I will get first times x times the derivative of the second, which is 1 over x, plus second times the derivative of the first. So I did the product rule real fast over there, okay? All right, now the goal is to solve for dy dx. But before I do that, I think the right side can be simplified a little bit, right? Look, x times 1 over x, that's just going to give us 1. Natural log of x times 1 is just natural log of x, okay? Now the left side, you notice, is dy dx times 1 over y. I want to get rid of this 1 over y. So the last step is to multiply both sides by y. Multiply this side by y, okay? So look what happens. This y and dy dx cancels out. 1 over y cancels out, leaving us with the final answer, dy dx equals. Now let's not forget. What was y, by the way? We know what y is, right? Give me 1 second, I'll go find that y for you. Y was defined as x to the x power. So this is the time we plug in what y is back into our final answer. So instead of y, say x to the x power times, and just copy down that parenthesis exactly the same. So that is how you can use logarithmic differentiation to differentiate x to the x power. So steps: take natural log of both sides. Next, differentiate both sides with respect to x implicitly. Solve for dy dx and plug in what y is back to your final answer. So that was the first example. Let me do another one. Example 2 is actually very similar to what you will see on your exam 3. So pay attention to this one for me, okay? Example 3 is that's a little too much. So I think I'm going to do that one in another video. But this is the one you want to pay attention to because I will ask you about this on your exam. Take natural log of both sides as soon as you notice, ooh, x is up in the exponent. So if I take natural log of both sides, this exponent of x can come down to the front, right? So this x will come down to the front. So what do I have? I have natural log of y equals x times natural log of 9x plus 5. All right, now time for us to take the derivative of both sides with respect to x. With respect to x. I'll move this a little bit to the side so that I can squeeze in d dx in front of it. Now you've done this one before, right? What is the derivative of natural log of y? Well, that's going to be 1 over y, but don't forget, you must multiply this by the derivative of y with respect to x. So you will write down dy dx. Okay? Now moving on to the right side, which we have a product going on. So we're going to take the product rule and use x as our first term and natural log of 9x plus 5 as our second term. So you can do your product rule pieces over here if you want to. So product rule for my red and orange. Let f be x, the first piece of the multiplication, then f prime is 1. Let g be natural log of 9x plus 5. Then the derivative of that is going to be 1 over 9x plus 5 times the derivative of the inside part, which will give you 9. So we'll put that on top of the fraction. So we got our 4 pieces. Let us do the product rule. So start with first times the derivative of the second. First times the derivative of the second. Plus second times the derivative of the first. Second times the derivative of the first. Okay, got it all. All right, let's see. So left side, let's keep it the same for right now. I wonder if I can simplify the right side a little bit before I multiply 1 over y. So I have 9x, see I just multiply those, over 9x plus 5. Don't you dare, do not do that stuff, okay? Don't cross out, okay? All right, plus natural log of 9x plus 5. Multiplying by 1 doesn't have any effect, right? So we're one step away. I'm going to just try to make these a little bit smaller so that I can squeeze in the last line, okay? All right, how do you get rid of this 1 over y? We're going to multiply both sides by y. Multiply both sides by y. So, look, final answer, dy dx equals, now this is the time for us to plug back what y was. So let's go back up and see what y was. Y was 9x plus 5 raised to the x power. So you're going to write that down. 9x plus 5 raised to the x power. So that's what y is, right? That's what y is. And then you just have to copy down this parenthesis exactly the same next to it. And that is going to be your final answer. So I'll ask you one logarithmic differentiation problem on your exam 3. And I'm going to keep it very similar to example 2 that we just did. Okay? Do watch example 3 if you want to know how to do something like this. You may see this one on your homework, but I don't plan on putting this on your exam. But this looks interesting. So let's do this one on another video.